but okay, I think we can start. Most people are here. Well, good day. Welcome to Developers Bay. I'm glad to be speaking here. I'm going to be talking about scaling in general. Of course, some of the part are specific to Google Cloud, but I try to make them like I try to give you the idea of how to do rather than be too specific on Google Cloud. My name is Julien Bisconti. I'm a software engineer. I specialize in Google Cloud. I have some specialization, as you can see here, and the reason I put them there is if you have any question in those areas, I'll be happy to help you. So if you have, any question, feel free to contact me on Twitter or through my website. I'm here to help. And so what are we going to talk about today? I'm going to start with a quite not so small introduction. I'm going to move on to what does it mean to scale code, because that's what most people think about when we talk about scaling infinitely. And I'm going to also touch on the topic of scaling teams, which is also something that I find a lot of startups run into, is they go from 5 people to 50, and suddenly it's not the same architecture. And then I will give you some conclusion about what I learned during those years. I have to give you a warning. It's a 45-minute presentation. I cannot tell you everything there is to know about scaling, reaching planet scale architecture for your application. I just give you some pointers. If you have questions, feel free to ask them. I'll answer the best. It doesn't mean I know everything. This is just, here is what I know, and I'm happy to share it. So, of course, that's why I came up with the term UE quad. It means unless you know what you are doing. And it means that whatever you do, unless you understand the trade-off, if you understand the trade-off, whatever you choose is right for you. That's what it means. And so what does it mean to scale first? Like, let's bring some context here. Well, there's 3 ways you can scale. You can scale vertically, which is basically adding more resources, more CPU, more RAM, more disk, more networking bandwidth. That's really straightforward. Scaling horizontally, it's a little bit more difficult because it means that you add more instance of an application to handle the load in parallel. That's an example. And then you have the really complex one, which is scaling deeply, which is a service calls a service calls a service. And then you have this chain of events that goes through a system, and that is quite complex. And I would like to take an analogy about where people live. Like if you have 100 people, this is called a village, right? There is probably more animals than there are people there. They have some roads, they might even have lights on the road, they might have some sewer system. It's like not very advanced, but it's good enough for what they do. Then if you move to a city, which is like 10,000 people, they have a different architecture, they have a different needs, they have to handle different loads. And it's the same if you go to a mega city. I'm thinking like New York, Tokyo, Moscow, those really LA, those really big cities, they have completely different architecture. They serve the same purpose, which is where people live, but the infrastructure and the way they function, they are completely different systems. And so that's why it's important to notice that we talk about the same thing, but it's different. And that is just to show like the latency number every programmer should know is that if you see on the left, it's very much the CPU cache level. So those are nanoseconds. And it's a really small number. But if you look on the far right of the screen, it's like a round trip from California to Netherlands is 150 milliseconds. And so you can see that there is an order of magnitude between each of them. So when we talk about speed, we need to know which scale are we on. And so one of the things that I feel is a little bit that I need to touch on is like when do you need to scale? Well, when you have a bottleneck. If you feel the pain of having too much load somewhere, you have a bottleneck. If you don't, you don't need to scale. It's probably that you have a people scaling problem and not so much a technical scaling problem. That's a little bit of difference. And I would say I'd rather give the answer right away. So, you know, if you're not here for that, is maybe just so you know right away what is the answer. From a startup with a product, a serverless architecture is a really good place to start, UEQAD, unless you know what you're doing. And the reason I say that is because almost you don't need to scale yet when you're a startup, but you might in the future. And that architecture allows you to do that. Nothing scale infinitely, but it will bring you there a long way. And so when you think about serverless, you have to think it the same way as Wi-Fi. It's more like at some point you will hit a wire. That doesn't mean that you have the experience that you see the wire. It just means that you have the experience without the wire. And that's what the same as serverless. You don't see the server, but they are there. And one thing I heard a lot, you know, working at companies, is that we should build our own X, and X could be whatever that is not related to business. And this is where, you know, the amount of tooling that company develop in-house is actually quite insane if you think about it. And so they build their own like technical solution for something that they could probably have bought or rent with a credit card and get it right away. So those things, it's for a startup is very much we could build it, but spending time on the business makes more sense financially. Meaning that maybe the tool you choose might not be the perfect fit, but it's there and it works. And one of the ways that I find that scale infinitely is actually no code. You know, the best way to write secure and reliable application, write nothing, deploy nowhere. And the most important part is this, the getting started. Start by not writing any code. And there is a whole repository of that where people, you know, make joke about it. If you want a good laugh, I highly recommend you check that repository. It's hilarious, but it's kind of like a joke that gives you the idea of like, maybe you don't need to write your own code for that. And everything is a trade-off, of course. There is no silver bullet. You want to, you know, build something yourself, you need to invest time and people, or you can buy a product, and that's going to cost you money as well. Either you are on premise, you have your own data center and your own server, and this is a fixed price and fixed capacity as well. But for the cloud, you have access to more capacity, but you pay only for what you use. So you have to be mindful of that. And of course, depending on your application, do you need latency, meaning answering really fast, or throughput is like answering a lot of requests at once. And of course, for serverless, we talk about the cold start problem, which is when a function hasn't been used for a while, it goes to sleep. And when it wakes up, it takes a little bit longer. So the experience is not the same. And I would say that if you have a lot of customer, that typically never happens. So problem solved, kind of. And all of those trade-offs depend on your strategy. And this is really for CTO and C-level executive, but it's really important that you, as a technical person, we understand that. On the y-axis, we have the value that we provide to the customer. On the x-axis, we have the time or the evolution of time. And you can see that on the far left, it's more like all that's research. You know, it's things that, you know, you need to invent and build yourself and make everything yourself. Like nothing exists. Towards the middle is like, yeah, you can rent, probably a company can provide you that service. On the right, it's completely like commodity, you know, like power. You don't say, you know, oh, you know, we're going to create a startup. Let's start by building our own electricity generator so we can have some servers, so we can, you know, like it's too far off. Nobody does that. And the person who actually invented that mapping is Samuel Wardley. I put the link in the slides so that you can, you know, check further. Everything is available for free. And when we talk about production-grade infrastructure, it's insane the amount of time it takes to actually make it good. I would say if you need to learn a managed service, it's pretty much 1 or 2 weeks. Like, you know, that's a database in the cloud. You need to learn how it works, to make backup, to, you know, learn a little bit about those quirks. And then if you have to build an entire cloud infrastructure, it's 6 months to 2 years. I think these numbers are very much if you don't have any legacy. That's when you start from scratch. If you're migrating, my experience is like more 5 years, and I'm really generous with that because it takes so long to rechange the whole architecture. And this, I put also the link of the talk I stole that slide from. So feel free to check that out. And when researching that, chaos engineering and architecture and disaster recovery, I found this paper that was from, just after World War II, and it's the pilot error experience in operating aircraft controls. So basically, they ask a bunch of pilots what was the most common mistake that was made while operating airplanes, and they said it was substitution error, meaning that they operating the wrong control as a result of a failure to identify a control properly. Meaning, because they were changing plane, the dashboard of the plane were not the same, so they could not find where is the control they needed in time, especially if you're up there fighting for your life. It might be good to have like muscle memory. You don't need to think, you just do. And by standardizing the airplane dashboard, not the airplane, just the dashboard, 50% of all the errors those pilots were making were gone overnight. So think about it, how we build our tooling. Maybe all the use case might not be handled, but having a standardized way to do things is very, very valuable because you're going to reduce the number of errors tremendously. So that was a little bit of the introduction about scaling and where you need to start. But really what we want to know is how to scale code. And so this is one of the questions I get asked the most often after, can I get a free subscription, Spotify, is should we use Kubernetes? And I said, that's the wrong question. You should have a use case and see if that technology works for you and figure out. I know that maybe later you need it, but my answer is always the same. When somebody asks me that, I say no, because that means they haven't think through, do they need that? Why would they need that? They just want to know, like, is it good? Am I going to be safe? You need to use your brain and figure out the use case and make informed decision about it. And so this is why I spent like 2 minutes teaching about Kubernetes and what it is and how it works, because it's a very simplified way of what Kubernetes is. Even though I've been using Kubernetes for years, I still feel like I don't know it all. And it's evolving every year. So Kubernetes is, in a GS, it's a database that holds the state of your cluster, meaning it knows what runs where. And so if you see here, you have 2 Kubernetes nodes, which is basically VM. They're running some pod, which, if you want, is containers or application. And what it is that you interact with an API server that itself interact with the database, which is called etcd. And so as a developer, you specify to Kubernetes how many instances of your application you want. Kubernetes would then check in this database what is there already. If there is 3 and you want 5, it will create 2 automatically, because the scheduler and the control manager automatically check what is inside the cluster. And so you can see that you define what you want and Kubernetes make it happen for you. So that's really Kubernetes in the gist. It's just, it's a database that holds the state of the cluster and reconcile the state with what you want. And so once you need to scale, of course, containers play a big part, but you still need to code your application according to the 12-factor app, and you get easier deployments. It's almost reproducible build, but there is no, it's not a silver bullet either. Just containers won't help you. Then you have, once you have your app in a container, you can scale up and down. How do you do that? You know, a container is just a container. It doesn't tell you how to scale. But all those problems, all those things are listed here. Kubernetes solve them for you if you have containers. And so that's why what Kubernetes is really good at. But of course, Kubernetes doesn't solve everything. Like, how do you store logging or tracing? How to do fault injection or, you know, circuit breaking? Those things are not embedded in Kubernetes. Doesn't mean that Kubernetes is bad or anything. It's just Kubernetes doesn't care about those problems. Those are for you to solve. It rather focus on scheduling and scaling. And so the way the people use that is usually they use code. A little bit of a parenthesis here, because when scaling to a lot of application, usually people, like most companies, use logging as debugging, and that is going to kill you way before any potential limit occurs. Because imagine you have one application, you split it in two, suddenly you have twice the logging, because one called the other, and then you have more logs, and this is exponential to the number of applications you have. So usually, if you have a microservice architecture and you use logging as debugging, the cost of all those files and data to store and be queried is going to kill you way before any technical limitation occurs. And if you want to do an exercise, just see the number of applications you have, multiply that by the number of the cost of networking, so sending those logs, and the storage, and multiply by the retention rate. So you see like how much logging is going to cost you, and the cost is usually insane. But what's the solution? The solution is distributed tracing. You want to have a correlation ID in the request that you pass down, so you can see where the customer request spread into your system. You want to see the whole system at once. You don't want to see one application just outside of its environment. And this is why tracing is really powerful, is because it helps you narrow down where in the system you have a bottleneck. And of course, Google Cloud allows you to do tracing and visualize that in the cloud. You don't need to reinvent the wheel. There are also open source projects that I'm going to talk about, but it's really the idea is to, if you need to debug with logging, you're going to have problems at scale. Like imagine 50,000 requests per second. What are you going to see in the log? It's impossible. You're going to spend, it's basically like trying to find a Facebook post that you saw 5 years ago. You're going to click next until the end of your life. So this is why tracing is important, is that you can see in a request what is the impact, the causality of one request to another system. And yeah, if I have one advice to give about how to scale, is to get your observability right from the beginning. Like really, there are books written about site reliability engineer, and observability means, how do you know what changed in your system? Like what changed? What happened? And this is where the question, your monitoring, your telemetry, everything, this is the question that needs to be answered by those tools. If they don't answer that question, it's probably not the right tool. And so I can highly recommend as well doing some chaos engineering, meaning breaking things. It's basically like being on call at 3 a.m., except that you had a shower and a meal before, and you plan, and you know how to recover from that. So it's really important that you test those things, because it will give you the confidence of what happened when things fail. And this is what, coming to the question of one of the participants, he asked me how to perform an error-free, test-driven proof of concept, which eventually lead to actual implementation of cloud migration. And when I read error-free, I say that's not going to happen. There is no way you're going to do something error-free ever. Actually, it's the contrary. Just expect chaos in your system. What you're doing by doing an experiment is to reveal the chaos in your system, because it's going to be there whether you want it or not. And so the best way to do is to plan for failure, recovery. This is what you do. It's more like, how do I never get injured? Well, even if you don't do anything, nobody is going to hurt. So it's the same. You need to plan for recovery. And also financial operation. Like, how many companies don't know how much they spend, or they have no control? Or I understand. It's more like, it's not a problem until someone says it's a problem. You understand? But if you know how much your infrastructure costs and how much a customer brings. You could have a very precise number that says, hey, it cost us that much per hour of downtime. Should we invest into reliability in our system or not? And this is where, you know, it makes people think, because you have an actual number to reason about. And I'm sorry to say, but I see a lot of companies doing, you know, having 10 languages in the tech stack, and this is craziness, because, you know, you remember that story about the airplanes and the dashboard. Just imagine how much tooling you need in order to actually observe and debug and do all those things that you need to do for one service. You almost need to change career to understand another language. So those companies that have like 10 languages, it's almost doomed to failure. It's like the cost of maintaining this tech stack is way too much. You cannot scale with that. And this is why I recommend to check, like, for distributed tracing, OpenTelemetry. This is what you want to see. This is what you want to know. It will tell you, it will guide you. It will guide you towards how does your system change. And this is what you want to know, basically. So it's not perfect, nothing is, but it will get you there further. And so this is also something like at scale, you know what, you won't need a test environment. Like, this doesn't exist. Because simply the condition cannot be met, cannot match production if you want. And this is why we see companies completely like wasting money, like on a staging environment that nobody uses, basically. No developer trusts it because the code there is just not working, or an operation usually use it to do their test because they don't want to hit production first. So it's completely useless to have a staging environment, and it gives you a false idea that, you know, you are already tested somehow. It doesn't replace your test. It doesn't change anything. It's better to write unit test and integration test and maybe end-to-end test that you run once in a while, rather than to have a staging environment. Like, this is, I think it's a total waste of money. You better, it just costs money to blow air. You better mine Bitcoin on it, or maybe I should not say that, but you understand, it's more like the idea of just wasting resources. And the reason I know that it's completely useless is this is the test. If you can deploy the same version of all your application onto the staging cluster and switch traffic to it without, you know, things blowing up, then it's not useful. Like, this is not a staging cluster. It's just, you just test your deployment today. And so just give up on the idea that you need to test in staging. Just be mindful. Just do like A/B testing or canary release into production. Those are much more, they have more cost up front, but they will pay off way more once you reach a high scale. And so also a question I get asked often is, should I use Terraform or Pulumi or whatever? And that's like, well, how often do you make change to your infrastructure? Those tools also have, you know, a cost of learning and a cost of maintaining. Just imagine you do a change and then 6 months later you need to do something else. Would you really remember how it works or how to do it? Or, you know, maybe someone changed something in the console because it's not locked down. And so unless you have a team that actually deal with infrastructure day in, day out, I think infrastructure as code is kind of just for the purpose of disaster recovery, meaning that if one region of the cloud blows up, can we redeploy to another region? And how often do you test that disaster recovery scenario? And this is like basically a chaos engineering game day. You have to plan for that. You have to dedicate time, people, you know, those kind of things. It takes time to get it right. But otherwise, it's really not, it's not worth it. It's going to take a lot of time and effort for something that you just forget about. I see I have some question. Let me see. What does that mean? Sorry, I don't.
It was not for you, Julien. It was for, we had a parallel conversation there. I got help from Stefan. Thanks.
Okay, very good, very good. So that the design team, okay. There are people chatting. Let me know if you have a question for me. And so this is the part where you have to realize the amount of code that's dedicated to your business logic versus all the rest, like all your containers, your manifest, your infra as code, your test, everything like that. And this shows you the total cost of ownership of creating a service, because you think like, oh, it's just a button on the front end for the customer, but behind in the system, there is like tremendous amount of resource that needs to be allocated for that. And this is where it's almost like an art to find this total cost of ownership. But let me take an analogy, build a buy. Restaurants buy, cook, and sell food. Very few do farming, and even less are good at both. And this is basically the summary of this talk. It's like, oh, you want to scale? Please don't do it. It's you don't know what kind of things, how much problem you're going to get from it. If you can avoid it, this is a good thing to avoid. Unless you know what you're doing, of course. And this is where it falls short, because your job is not to build a data center. It's probably to sell a product. Your job is probably not to manage infrastructure. Is probably to build features. And you understand, it's all those things that how much time do you really spend on the business is what matters. And this is where through it many skills. Like look at this is Mr. Mohapatra. He's the person who actually built the physical data center of Google. And he says, so Lyft is paying $8 million a month to AWS, almost 100 million a year. Each ride costs 14 cents in AWS rent. Like, see, they already know how much each ride costs. That's something you really want to have as well in your observability. I keep hearing they could build their own data center and save. My early days at Google Cloud, I heard the same from customer. At scale, owning is cheaper. It wasn't. They all came around. Here is why. And they go through the cost of basically owning their own data center, which is like so huge. They forget they need to have guards to keep at night. That was not in the cost. They just see VM to VM comparison. Like, of course, buying just a VM is cheaper, but in the cloud, you have different things that are probably not stated. Like you don't care so much about those details. And that's the beauty of it, is like you can get it. But so we talk about compute, memory, storage, networking, and all those things. Yeah, they are technical things you can scale, but what is the thing that's missing here? That's security. And that's the real cloud lock-in. Like, doesn't matter, even you build your own solution, your own data center, security is going to be proper to that data center and the tech stack you use. Doesn't matter each cloud, they kind of have a different level of granularity for every service they have. So to mapping those, it's almost like too costly. I would highly recommend that you let that sink in, that doesn't matter the cost of something, is probably you're going to get locked in at some point. So make it count, use it good. And this is where in Google Cloud they recommend you, like if you're a 10,000 employee company, this makes total sense. Like you have department, like an organization that can be split into folders, that can be split into projects, and inside those projects you have resources like bucket, VM, whatever. This is a death sentence for a startup, because you can be sure that team B is never going to know what team A is doing. And this is kind of like a design that is meant not to change. You understand? This is not for startup. This is definitely not for when you start. You don't want that. You want something simple, because simple scales. And so on GCP, you have different level of access, right? You have those organization folder project resources. And then you can assign group of people or one user, or even an application, which is called a service account, which basically it's literally a file that is a certificate or a public key with a name. And all of those things are going to evolve with your startup. And it's good to start early to monitor and have the tooling to manage those things, because you're going to go to IPO maybe. And suddenly you're gonna have those audits and those different requirements. Like you need to restrict access. You have to have peer review on some resource, and all those things to prevent somebody to hack basically the system, even if it's an internal employee or an external hacker. And so we talk about, you know, all of those things, but there's still one thing missing that we don't think about, and that's data. And basically, your customer, they don't care so much about your code. Like nobody cares about your code but you. Not even your manager cares about your code. You have to deal with that. That's your job. And so if you're a developer, that's exactly like what you should focus on. But your customer, they care about the data. The same way you go to a bank, you don't ask about the tech stack, otherwise you would probably run away. Or you don't ask about what is the security model. And this is the same thing, like your customer as well. But if you have a lot of data, usually you start with a small database. And this is like the 4 steps you have to scale database. And they go increasing order of complexity. So the first one, the easiest one is just to add more RAM and CPU. And this works, you know, it's fast, the fastest and the simplest. The second one is to optimize the queries. You know, it might take a few days to get it right, but at least it can save a lot of performance. Then we reach into, okay, you have read replica, meaning that you write to a single one and those writes are replicated to different clone database, and the client read from that. But all the write are separated from the read. And that scale already pretty well, but of course you have a bottleneck, which is the single write. So if you have too much write on this one, it's not gonna scale. And at that point, what you need to do is sharding, meaning that you take, it's usually based on a key, and the key will determine which of the database you're gonna store this information to. And this is a level of complexity tenfold. You understand? You really have to make everything work, and you can see like each one of them is a tenfold increase in complexity. So start simple and go from there. And of course, Google Cloud allows you to, you know, they already figured that stuff out way before, you know, we even talk about these things. So Spanner, you can do transaction at scale, planet scale. Like if you need a SQL database, it costs more because there is a lot of machine and a lot of replication going on, but you get it. Like it's possible to buy now. 5 years ago, it was not so much. BigQuery, you can do analytics on like petabyte of data in minutes. Or Data Studio, you can visualize the whole cloud infrastructure, all the costs, everything that you can think of in, you know, in your cloud infrastructure. And even if you want to do AI, there is this open source project called Kubeflow, and Google has also this managed Kubeflow, if you want, with extra features and integration to other services. And this, for most data scientists, somebody throw a Kubernetes cluster at them and say, go ahead, figure it out. And so they are there and they're supposed to do machine learning, and all they do is chasing data and figure out, you know, containers and all those things. So they have to redo the same job as a developer on top of having all the other problem as well. So those kind of services really help if you have a startup and you don't have the resource to maintain like a clusters. Those provide you much fastest result. You also have the cloud asset inventory, because most of the time you want to know, you know, if you have more than one team and you give them autonomy, they're going to create resources, but you still want to know what you create. If you start creating clusters that just, you know, because you've been hacked and somebody started mining Bitcoin, it's really something you want to be aware of. Otherwise, you get a lot of surprise. And even though that, maybe your application scale and you get a tons of customer and you want to know where your costs go. So it's really important to have those kind of you know, data. You want data about your cloud infrastructure. Okay, so that was a little bit about scaling code, but now I'm going to touch about scaling people, and it's typically the question you might have to think about is what happened when we need to scale people, because you cannot do everything alone. And one way you can go is to either outsource that to a company, or you bring people in-house. And most of them choose in-house. I don't know why. Sometimes, you know, I see company of 2-3 people and they're doing just fine just by using services. But if you need to hire, you need to have a really strong culture, because going from 10 to 150, those 10 people who were there at the beginning, you won't see them. It's completely different. And if you hire people, how do they learn this stuff? It's not enough to throw a learning platform at them, hoping that they will take an hour a day, you know, in between meetings to actually learn something. I don't believe that's how we learn. I believe we learn by doing. Onboarding, if it takes 6 months for someone to be productive in your company and they leave after 8 months, well, you pay someone to learn your tech stack, basically. So I'm not sure it's working out for you. Communication tool and process. Yeah, if you have three chat app, how do you know who said what to who, and you know, where do you find this information? It's really complicated. Think about the dashboard again, the plain dashboard. Like one way to talk, one way to store document. This is gonna simplify the process a lot. Management and clear objective. This is what I learned at Spotify, is that really management is there to provide clarity. Like they should tell you which problem you need to solve. And if they don't, it's probably their task. You should tell them, like look, I want to know. And this is what I've seen with the brilliant people that I've met, is this is what they do. The greatest people in management, they just provide clarity on the task. Like, what is the goal? And also, if you want to see, you know, it's sad, but finance is still working like we were doing in the 80s, because they release once a year, right? At the end of the year, they have to close the book. And this is where usually it does not work if you release once a year. But what if you can help and close, you know, do something before that? And you know, practice is the DevOps way. Do what you're not good at often, so you get better. And so this was the part of the people, because I think that finance is a big role in it, and they should be included as well into whatever discussion we're going forward, because they might need some tooling as well. Now everything is digital. They might need an engineering team to build a tool to help them get faster, and they might not be able to even articulate what they need. And so that's why it's really important that those people get on board early. So the conclusion is that a tool won't fix a bad process. Automating a bad process makes it automatically worse. I think that makes just sense, but time is money. Yeah, if you need to build something, it's going to take way longer than you expect because of all the details that we haven't thought through. Document your architecture decision, because you know you're going to be wrong. Like we make decision and we don't know if we're right or wrong. We might be, you know, but it's not sure. And so documenting the reason why we take a certain path will make it easier for us to change it in the future. So documenting architecture decision doesn't mean this is the law and that's how it's going to be always and forever. It's more like, hey, this is what we knew at the time, and we chose that path because it made sense, or we didn't know any better. You can revisit those questions, say, okay, do we have the time to change that? Does it make sense? Can we go further? And also, like microservices, they help to scale, but it's more like they help to scale people more, because they allow you to ship your organization, which means that it's Conway's law. It means that a system will mimic its organization and vice versa, like they impact each other. And think of it as, if you ask 3 teams to build a compiler, you will get a 3-phase compiler. That's the idea. So microservices, the way they communicate between them is the way people are going to communicate between them. So it might make sense to have cross-functional team and switching people around very freely if you want to really scale. Like, your microservice architecture. And this is why the consistency is important across those services, because if every team has a different tech stack, no one can work on anybody else's code. Also, know your bottlenecks. It's gonna happen. Sometimes without scale, people create bottleneck. I'm guilty of that, so I can tell you. I've DDoSed myself a few times. I've made a big mistake. And that's why I've become interested in observability and really monitoring and knowing what's going on, because it provides so much valuable information that you feel more confident about your system. And yes, security, I don't know if you saw the number of companies that get hacked or data leaks that happen all the time. Every week, there is a security newsletter. I just look at that, and there is like 5 to 10 every week, just the one we know about, and this is your data, this is your family's data, this is your friend's data that gets leaked. So it's kind of like, it's good to have this mentality from the beginning that we're going to monitor who has access to what, and invest time and energy into creating the tools for our security, because it's also like you're a customer to some place, and it's better if we solve that at the beginning, especially before we scale. And so the mindset is you always be migrating. You never be error-free and done, and that's okay and sure. It's actually a constant, especially at scale, it's a constant state of unknown. And it's always, we have to test, we have to check, we have to verify. It's never about, you're never sure. It's really important to internalize this, that you never be done. You really focus on your being humble and knowing that you're going to be wrong, because you cannot know everything. And this brings to the last conclusion, like, be careful what you wish for. Scaling is actually really hard. I spent months just making sure, like, developing a small services and just trying to deploy it, and making sure that the traffic was right and the data was right, and talking to a lot of people. I had a friend, an ex-colleague, he told us that during a retrospective, he was telling us, I have social anxiety, and I took this job because I thought I wouldn't have to talk to anyone, and I ended up talking to everyone all the time because of they have to synchronize so much into all the microservices they have. And this is just to illustrate that this is really, really complicated, and you can avoid most of that thing by outsourcing those problems to external company that specialize into that, instead of building your own. It's really important, because the learning curve is quite high, I would say steep. But if you want to do it yourself, there is this one book that will teach you about 80%, 90% of what you need to know about scaling. And that's Designing Data Intensive Application by Martin Kleppmann. I have this book here with me. It's like, if I had this book before, I would have saved days of agony and pain, debugging and trying to figure out what's going on. Also, when it comes to architecting something, it's a really good idea. This should be taught at university, really. And also this paper, Shifting Left on Security, because the earlier in the process you do security, the more scalable it's going to be, and the more you can actually help the developer. They don't want to reinvent the wheel all the time. That's what I mean. It's better to start early with that, and not let them figure out once the service is in production and handling traffic 24/7. This is a really bad time to change something. And as always, thank you for your attention. I'm sorry, because throughout my career, I wrote way too much code. And if you have to maintain my code, I hope that you learn more by maintaining it than me by writing it. If you have any questions, feel free to contact me on Twitter or through my website, bisconti.cloud. I hope you enjoy. Let me know if you have any questions.